So now we're going to take a look at the addition rule or non-mutually exclusive events with probabilities using, these are called contingency tables. So if you see these tables right here, basically we've got a lot of different things going on. It's a very, very nice way for us to get this data organized. So before we start, this says the pet store has cats, rabbits, and gerbils, 7 black cats, 4 yellow cats. That would be a total of 11 cats. 8 black rabbits, 3 white rabbits, that's 11 rabbits. 3 orange gerbils, 5 white gerbils. That's a total of 8 gerbils. So how would we get the total number of animals? We would add these up. 11 plus 11 is 22, plus 8 is a total of 30 animals. So this contingency table, you see that we have rows and columns corresponding to, the rows corresponds to the animals, and then the columns correspond to the colors. So we know that these totals for these different animals are here, the total number of animals right here, and then basically what we're going to need to do is 7 black rabbits, 4 yellow rabbits, no orange ones, no white ones. And 8 black rabbits, no yellow rabbits, no orange rabbits, but there are 3 white rabbits. Finally, the gerbils, there are no black gerbils, there are no yellow gerbils, there are 3 orange ones, and there are 5 white ones. So to get the total for the colors, we're going to add this down. 7 plus 8 is 15. 0 plus 0 plus 4 is 4. There are 3 here, then there are 8 here. And again, if you add this across, you should get the same number when you add across or down. So it says procedure, place all the animals in one area and randomly choose one animal. I would not suggest putting all of these animals in one area together. That would not go very well, but let's say we put their names in a hat or number them. So what's the probability that I get a cat? So you take a look, you can see that we have 11 cats out of 30 total animals, so the probability of getting a cat is 11 out of 30. A rabbit, also 11 out of 30, right? Because we have 11 total rabbits out of 30. White animals, how many total white animals? We're going to read the column now. These are the total. This is the total for the white animals, right? So that would be that one right there. And so that is what? That would be 8 out of 30, which we're going to try to reduce that, right? So if you have a TI-30, just hit 8 and then find that ABC button and then hit 30 and then it will simplify you. If you have a graphing calculator, which again is not necessary, whoops. All right, sorry, let me get out of here. All right, 8 divided by 30, and then we hit math, enter, enter. Again, if you're having trouble simplifying a fraction on your calculator, please send me an email and I'd be happy to show you how to do it on your specific piece of technology. So this would reduce to 4 over 15. All right, so now we're going to start working on events, and we're going to try to figure out, are the events disjoint or not disjoint, if they or mutually exclusive or not mutually exclusive, and then based on that, we are going to find these probabilities. So what we're looking for, remember, not disjoint events that are not disjoint have overlap. So when I take a look at my first situation, it says find the probability of getting a cat or a rabbit. Ask yourself, are these disjoint or not? Are they disjoint or are they not disjoint? Well, think about it. Can you have a cat that is also a rabbit? Can an animal be a cat and a rabbit at the same time? The answer is no. So this one would be disjoint or mutually exclusive. So the probability of getting a cat, and this is again, we just get to add these. The probability of getting a cat is right here. It's 11 out of 30, right? And then we do plus the probability of getting a rabbit is right here. And that is also 11 out of 30. And you see, this is why I like to circle this. You can see that there isn't any overlap. You see they don't cross each other. So the probability of getting a cat or a rabbit, we just add those together, 22 out of 30, which again, we could use our calculator or just, I know I can divide the top and bottom by 2, and I get 11 over 15. All right, so I deleted my circles because I'm going to circle this multiple times. Cat or a white animal. So we just have to ask, are there any cats that are white? And in our case, we're going to see that there aren't any in our sample, but I am going to show you this is the first time we do see there is some overlap. So we would say that these are not disjoint. Again, because there are such thing as white cats. Just say, are there white cats? And the answer is yes, right? So that's why we would say this is not disjoint. So we're going to do, let's do the cats first. We're going to find the probability of getting a cat, which is right here. We did this in the last one. We can see that's 11 out of 30, right? So the probability of getting a cat is 11 out of 30. And now we're going to do the probability of getting a white animal, which, where are all of our white animals? That is this right here. And do you see that, can you see the overlap? This is really, really important. The overlap is this 0 right here. So there isn't anything in that space, but this is an example that we do have some overlap. So the probability of getting a white animal is 8 out of 30. Again, don't reduce your fraction till the end. And then we're going to subtract the overlap, but there isn't any overlap because you can see that overlap, there's nothing there. So 0 out of 30, that's going to be easy. So 11 plus 8 is going to be 19 over 30 because minus 0 is nothing, okay? All right, the next one we're going to take a look at is getting a rabbit or a white animal. Just think about this. Can there be white rabbits? That's true. So we're going to say this is not disjoint. So to find the probability, we're going to do rabbits first. So the rabbits are this row right here, and how many of those are there? They are 11 out of 30. Plus, now we're going to do the next one, which is white animals. And the probability of getting a white animal is right here. And that one is, 8 out of 30. And now let's look for that overlap. You see where that overlap exists? It is right here. And how many of them are there? There are 3 out of 30. So again, this is where you have to subtract because that 3 got counted twice. So we did all the rabbits plus all the white animals, and then we're going to subtract this overlap of 3 out of 30 right there. And so now 11 plus 8 is 19 minus 3 is 16 out of 30, which would be 8 over 15. Why don't you hit pause on the video and try this last one to see if you really understand what's going on here. So try to find the probability of getting a cat or a black animal. Ask yourself to find if they're disjoint or not, and then go ahead and see if you can calculate the probability. So I think in this case, these would not be disjoint, right? So they would be not disjoint. Oops. Because again, there are black cats. So we're going to do the probability of getting a cat first, which is, again, 11 out of 30. Plus, we're going to do the probability of getting a black animal, which is right here. So that one is going to be 15 out of 30. And then we just need to subtract any overlap. And you can see you're kind of looking for the T and the cross. That's right here. This is going to be that overlap. So we're going to subtract 7 out of 30. All right, so 11 plus 15 minus 7. So 11 plus 15 minus 7 gives us 19 out of 30. So the total probability of getting a cat or a black animal is 19 out of 30. Okay, let's take a look at this next one, which says there are 25 men at a party. 10 of the men are bald and 17 wear glasses. Randomly choose one of the 25 men. What is the probability of choosing a man that is bald or wear glasses? So we're going to try to do the same thing. Is this disjoint? We're going to say this is not disjoint or not mutually exclusive. And why is that? Because there are men that are bald, right? A lot of bald men, or I'm sorry, there are bald men who wear glasses. There are a lot of bald men who wear glasses, so this is not disjoint. So let's do the probability of getting a bald man, which is 10 out of 25, right? And then the probability of getting a man who wears glasses, which is 17 out of 25. And then I do minus. What are we looking for? We need to know the number of bald men who have glasses. And I'm stuck here because you see they tell us the men that are bald. They tell us the men that wear glasses. But do we know the overlap? No, it doesn't tell us. Some people might be tempted to try to subtract these. That's not true. We don't know how many bald men wear glasses, so we can't do this one. So we can't solve this one because we don't have that overlap. All right, and one last one just to bring this home. Again, I encourage you to go ahead and hit pause and try this one before I do it, and then see if you can get the right answer. Again, it's good practice to try this first, okay? So one of the things that I notice is that there aren't any totals in this. So if you have a table that does not have totals, I'm going to encourage you, let's extend this out and let's get totals for all of these. So what's going on in this situation? We're asking kids if they own a toy car and then asking them again if they own a toy truck. So you can see that this right here, this should be up here. This is the truck. These are all the kids who said yes, they own a toy truck, and then these are all the kids who said no. So 35 plus 25 is 60 kids said yes to a truck, and 30 plus 10 is 40 kids said no, they don't own a truck. Then we asked kids if they own a toy car. 35 plus 30 is 65 people owned a toy car. Again, we're going to do totals down here. 25 plus 10, 35 kids said they do not own a toy car. Again, we asked a total of 100 for this. It says if you randomly select just one child from this town, what is the probability that the child either has a toy car or does not have a toy truck? So what are we finding the probability of? We want to find the probability that it's a yes car, right? Or no truck. So we're going to need to break these down separately. Let's start with how many kids said yes, they own a toy car. So the number of yeses for toy car is right here, which is 65 out of 100, right? And now we're going to see it's no to a truck. So who said no, I do not own a toy truck? So people who said no to a truck are right here. And we see that the people who said no to a toy truck was 40 out of 100. So there were 40 kids who did not own a truck. And then you see what we're looking for now is we're trying to find that overlap. Whoops. So we're trying to find that overlap. So we look for the overlap, and you see it's right here. So we need to subtract that off at the end. Those are the people who said yes, they own a toy car and no to a truck. And that is 30 out of 100. Sorry about the page moving. So now we're going to add these. 65 plus 40 is 105 minus 30 is 75 out of 100, which we would reduce to 3 over 4. Please remember you can do 0.75 or 75% as well. So these take some practice. So after you get done with this, I'd encourage you, go take a look at the homework, try a few extra problems like this, because again, it's nice. The best way to get this down is to go practice right away with this.